welcome you all here and apologize for my inability to talk to you in German. It's been about 30 years since I learnt German, and back then it was poor. Now it probably wouldn't even rate. So I'm going to hopefully speak to you all, and if you have any issues with anything I've said, either grab me later or shout out, and maybe I'll slow down a little bit. So I'm going to talk about whether enterprise Java is ready for the cloud and for mobile, and give a quick overview of what we will cover. So I'm going to talk about where we are today, what has brought us in terms of hardware and software forces to the point we are in 2012. Touch on mobile and cloud. That is the subject of the talk after all. And what both of these mean for Java, the JVM, and for Java middleware. And I'm also going to look at Java in the future, and particularly in terms of standards and changes that are going on in the Java Executive Committee, which since for the last couple of years has been, I wouldn't say ruled, but has been directed by Oracle instead of Sun. And I'm going to finish off with some open areas of interest and research that I think, as a Java group in this room, we still need to address. As I was just saying earlier, I think actually, hopefully by the end of this presentation, you will come away with realizing that I think the future is certainly Java and the JVMs to lose. There's an awful lot of investment that we have put into Java over the last decade and a half, and there's still a lot more that we can get out of it if we're willing to make some changes and embrace these things. So before I actually launch into this, just some quick background. Although I am here representing JBoss, I run all of JBoss engineering. I took over from the previous JBoss CTO in 2009. I'm going to try and be as objective as I possibly can. I think I've only got maybe 2 slides that really talk about JBoss or Red Hat. So I've been involved in fault-tolerant distributed computing since 1986. I did most of my work around a system called Arjuna, which is or was a distributed transaction processing system written in C++ and then eventually into Java. I've worked in areas including DCE, DCOM, Corba, obviously Java. Many of these, hopefully, you will have heard of. And active in a number of standards efforts, including, obviously, the Java community process, but OMG, Oasis, W3C. And, for my sins, I've been an author of a number of web services standards, as well as those coming out of these other bodies, including the OMG. So, as I said, let's touch on where we are today and what brought us here. Hands up if you have experience of one or more of the things on that slide, some of the pictures. I'm hoping it's not just me. Good. Because I gave this presentation a while ago to a group at our local university, and apart from in a museum, none of them had seen or heard of any of these. And I felt like maybe I should walk off the stage and not talk to anybody. So, this is like 30 years ago. ZX81s, 1K of memory, 16K expansion pack if you could get it to stay on. BBC Model B, 32K of memory, but really only 29K. And, floppy disk, 68,000, sorry, that's a 6502 8-bit microprocessor. This was computing 30 years ago. That there is a workstation that was, it's not my photograph, but it is a photograph of a Whitechapel workstation, which predated the Sun 350, and that was my first workstation back in 1986. If we look at where we are today, it's very, very different. And hopefully all of you have experience of one or more of these things. We've got quad-core processors in our laptops. We've got, that's a 256 gig memory stick at the bottom of the slide. You can get 512 gig memory sticks now. Workstations are significantly more powerful than they were back in 1986. So the times really have changed. And here's another example. That's a Motorola 6840. That was pretty much in that workstation that I showed you in the previous slide, the Whitechapel. And the example on the far right, the far left of the screen there, is a 16-bit microcontroller. It's 5 years old now, so you can probably imagine what you can get today. It cost less than $2 then. It's an eighth the size of that US penny. It could handle 16 parallel streams of information, and it had more power than the 68040. And that is what we tend to think of today as a constrained device. And yet, the 68040 was never called a constrained device. It was what we expected if you were working in academia or in industry. It was your world. You were able to do a lot with that. You were not thinking it's a very limited thing. You probably were when the next generation of processors came out, but at the time, you thought it was the be-all and end-all of hardware technology. So let's look at where Java was over a decade ago. So we were with J2 SE 1.3. We were in between J2E 1.2 and 1.3. Your typical laptop configuration was a gigahertz Pentium 3 with 512 meg of memory. It was exorbitant if you had a gig, and if you did have a gig of memory, you were probably paying about what you would expect to pay now for a top-of-the-range Apple laptop. 20 gig of disk space was pushing it, but that was sufficient to run the full stack. The full Java J2E stack could be run quite nicely on that configuration. Mobile devices back then, however, were extremely limited. And here's just an example, a thing called an HP Janata 720. Has anybody ever used an HP Janata 720? Anybody? 2? Yeah, okay, I have. That makes 3. So, it's a 32-bit microprocessor from HP. It had a keyboard. It was about that big. Touchscreen, ran Windows CE. This one here ran a version of HP's JVM called Chai, which was 1.2. But it was still sufficient to run some components of J2EE. So certainly when I was in HP at the time, we had our transaction service running on one of those things. I wouldn't say it ran particularly fast, but it did run. And if you look here, this is a graph of mobile chips versus that Pentium 3. Yes, of course, the Pentium 3, bigger is better, or longer on this track is better. Pentium 3 has very, very good floating point index compared to anything else. But if you look at the very bottom graph, the Snapdragon processor, which is in the Nexus 1, which is already over 2 years old, that is a mobile chip, and that is not doing too bad. It is beating the Pentium 3 of over a decade earlier on, integer arithmetic. And hopefully, again, some or all of you in this room will at least have heard of the Raspberry Pi. You may or may not be even responsible for bringing down their website 5 minutes after they put them on sale in January. The thing on the other side is a BeagleBoard, a little bit more expensive than a Raspberry Pi, but if you look at the specifications of these things, just looking at the BeagleBoard, it's got 1,200 MIPS. It has HDMI output. It's got 256 meg of memory. That, compared to the Pentium 3 laptop that I mentioned earlier, would blow it away. And yet, certainly the Raspberry Pi is being marketed in the UK at something like £20, which is probably about 20 euros, as a device for people to play with, for kids to actually get to grips with hardware. It comes with Linux on it as well. So that is, again, that's being called a constrained device, and yet it would blow away the laptop that I was using over a decade ago. So, Java in 2012, you should all pretty much know this. We're on SE7, moving quite rapidly towards 8. We're into Java EE6, and there's a lot of work going on now on 7 with various JSRs. Your typical laptop configuration is probably going to be something like this, a quad-core CPU with at least 4 gig of memory and a 500 gig hard disk, and maybe that hard disk could be even solid state. It is definitely sufficient to run multiple versions of the EE6 stack, possibly even in different operating systems at the same time with virtualization. And smartphones, well, probably in this room, at least 50% of you will have iPhones, but hopefully the rest will have some combination of an Android. Here's an example: the Galaxy S2 dual-core, 1.2 gig, Cortex A9 processor, running Android 4, and that is sufficient to run many, if not all, components of EE6. I know, because that's pretty much what we've been doing over the last 12 months, is trying to run our stuff on Android. I say all in question marks in that I don't actually think there is anything fundamental in the hardware that would prevent a full EE6 stack running on an Android device. It's probably going to be limitations in Dalvik and the language itself. But in theory, if those things can be improved and changed, then the full EE stack could run on an Android device today. And we're already seeing people talking about having virtualized mobile phones. So you have a phone that can run multiple operating systems at the same time. So you could have a single phone, instead of, as I have a personal phone and a work phone, you could have a single phone that has 2 VMs and essentially 2 phone numbers, and one is your personal phone number and the other is the work. And depending on which number rings, different version of the VM will actually flip in, be paged in, and actually answer the phone call. So, Java today is significantly different to what it was over a decade ago. The hardware is significantly different as well. You can't have failed to have heard about cloud. I know that we've had presentations over the last day or so talking about cloud. Public cloud, we've heard a lot about this over the last few years with the likes of Amazon, EC2, and Red Hat has a cloud called OpenShift. Very, very important and very, very useful today. It allows us as developers to really get on with what we want to do, which is develop the apps and not have to worry about how I configure the underlying platform or infrastructure, because it should be configured for me pretty much out of the box. Private clouds, although a few years ago they were pretty much ignored and even to a degree put down by various vendors, notably the public cloud vendors, I actually think private clouds are probably going to be even more important than public cloud, because there are a number of vertical sectors, and you may be involved in some of them, that will never really be able to move to public cloud for legal reasons, for reasons like they just have so much data, there's no way that they could even get it into the public cloud, and then there's the security issue from there. So private clouds, although they haven't been a big part of the last few years with cloud development, they definitely will be as we move forward, and we're already seeing that. Even with some of the public cloud vendors now starting to talk about and offer private cloud versions. But, as hopefully we've seen over the last few slides, ubiquitous computing is here today. If you were in the industry 10 years or so ago, Around about the time of that HP Janata, you would have heard companies like HP and IBM talk about ubiquitous computing, talk about how it shouldn't be that long before your light bulb has an IP address and you can actually telnet into it and switch it on. Your oven will have an IP address and you'll be able to connect to it on your way home and tell it to switch itself on and start cooking your dinner. 10 years ago, that was really pie in the sky. It was blue sky. It didn't really happen. Today, it is a reality. There are more mobile devices in the world now than there are human beings. I'm not just talking about mobile phones. I'm talking about sensors, RFID chips, that sort of thing. Most of them have TCP stacks, which means, obviously, you can connect to them if you know the right protocol. So ubiquitous computing is a reality today. And I was in a house of a guy, I won't say what company he works for, end of 2011, who actually does have IP addresses associated with every single one of his lights. And he can connect to them from his laptop and switch them on and off, dim them and all that. I don't know whether it really is that useful, but he has got what was told by HP, IBM 10 years ago. It is a reality today. So that, I think, is the real cloud. Today, when we think about cloud, we think about, as I said, the likes of Amazon. We maybe think about virtualizing and cloudifying our back-end infrastructure for a private cloud. It's still very much server-based. The real cloud is this ubiquitous computing. You will be able to tap into your fridge, your oven, even your lights, I suppose, if you really want to. And it may not, it's like everything. It may not be what these manufacturers expect, but I'm a developer. I've been developing for the best part of 30 years, and I'm sure this is a sentiment that many of you will understand. If I can do it, I'm probably going to try and do it. If I know that my washing machine, and I do know this, has a CPU in it and memory in it that blows away my laptop of 10 years ago, I'm going to actually want to try and see what else I can do with it when it's sat there not doing anything, when it's not on a spin cycle. Can I connect to it? Can I actually use it? And I obviously do not condone any of this, but there are people out there who want to use this extra CPU capability in their homes for ripping DVDs. I mean, ripping a DVD on a laptop does take a while, but if I can stream that off, if I can map reduce it, for instance, and have my fridge and my lights and my washing machine doing these things concurrently, it's going to save me a lot of time. I will repeat, I don't do this, and I do not condone it. But and then there's this thing called Shannon's limit. I don't know how many of you have ever heard of it. If you haven't, I encourage you strongly to go away and read about it. You don't have to get down into the full maths behind it to understand what Shannon's limit is. But basically, Shannon's limit is, it's a fundamental law, it's physics. It shows that the amount of information that can be transmitted reliably over a given connection is limited. That there is an upper limit. Doesn't matter how much you want to push down a particular stream, whether it's an Ethernet cable or whether it's Wi-Fi, at some point you will reach this limit. And this is extremely important for cloud, because at the moment, cloud is kind of working. Public cloud is working. Private cloud is going to work, because not everybody is using it. But if we all start to use cloud, and I think it is inevitable that many, many more people will use cloud, we are going to rapidly run into Shannon's limit. It does not matter whether Amazon put the latest processors in their back office systems, in their warehouses, wherever they are. If you can't get your data to them, if you cannot get answers from them, then you are going to start being annoyed with cloud and turning away from cloud. And whereas up to this point, mobile and cloud have kind of been evolving separately, they actually do need to work together. So in order for cloud to really be something that the masses can use, we're not going to be able to rip out our infrastructure, our network infrastructure. It's going to, if we were to try and do that, it would take years, it would take massive amount of money, and it simply is not going to happen. It probably wasn't going to happen prior to 2008, but after 2008, with the global economy taking a dive, I don't think we're ever really going to see that. So the era of thin clients has really gone. And in order for cloud to really make an impact further, it needs to be hooked up with mobile. The mobile, kind of like the ubiquitous computing that I was mentioning before, they're going to have to become an integral part of the cloud and do a lot more work for us. So, over the years, certainly over the last few years, with cloud getting more and more popular and mobile getting more and more popular, I've heard, and maybe some of you have, many of the things that are in quotes here. Like, middleware is a 20th century technology. We don't need middleware today. But, we've heard this before, or at least I have. We heard it with web services. When web services came along, it was, oh, well, middleware is completely defunct now. Web service is going to be a completely new area, and we can start from scratch. We heard very similar things with the web back in the early 90s. Even when Java came on the scene, Java was the death of middleware. Java was the death of C, C++, and C was the death of COBOL. We've heard things like mobile needs new frameworks, needs new languages to succeed. But, hold on a second, let's actually look at the two most popular mobile platforms that are out there. Android, it's Java. I put it in quotes because, there's this court case going on, so whether we can call it Java or not is going to be decided elsewhere. But, to all intents and purposes, it is Java. The iPhone, the iPad, Objective-C. Objective-C is a language that, came about 20-odd years ago. And then from cloud vendors, we've heard some similar things. In order for cloud to succeed, platform as a service particularly, we need new infrastructures. And we need new services and new languages. But one of the things that cloud originally started off for was to allow existing applications to be a lot easier managed and scale. If we're looking at new languages and new infrastructures, then we're ignoring the existing infrastructural investment, the existing applications that cloud was originally designed for. And that doesn't make sense. Yes, there will be new applications that are designed and developed. There always have been. But for cloud, if you look at the most popular cloud infrastructures that are out there today and what they offer, it's languages that have been around for decades. Ruby, Java, PHP, Perl. Okay, JavaScript hasn't been around for as long as, say, C or C++ or COBOL, but there's still a lot of old legacy apps, if you like, and old legacy languages that are being supported on cloud. So, I don't agree that cloud and mobile are the death of middleware or the death of existing languages or existing infrastructures. I think, hopefully you'll see in a few slides, that it's yet another wave that we need to evolve with, or maybe it will be the death of Java. So, there's if you look back over however long you've been in the industry, even there have been enough changes over the last couple of years for you to see some of this as well. We kind of have a variant of Parkinson's law at work, and again, it's fairly obvious. Work expands to use the power of the machine that's available to you. Very first PCs had very, very basic word processor capabilities, and you had people who were working in the media who were sniggering at things like WordPerfect when it came out. And there are lots of people, and I still know people today, who still use LaTeX because it looks better, they say, even though it can often take a hell of a lot longer to make it look better. But today, we take for granted really good word processors on our laptops. Word processors that would blow away what we were using 20 or 30 years ago. Games. I did play Pong, and Pong was the very first game I can remember playing on a machine that was probably like that big and plugged into the mains. I played Space Invaders and Donkey Kong and all that sort of thing, and they were cutting edge back then. I look at things like Call of Duty today, and I think, Jesus, if that was available 30 years ago, I probably would have had a completely different career and been even less of I've been more of a games player, I think, than I ended up being. Mobile devices contain more and more of our data. We're taking them more and more for granted as well. Things like NFC, near-field communication, where I can take my phone and I can swipe it past a sensor and buy a car, potentially. They are an integral part of our life. Many of you probably could not live or work without your phone. I know I have an 18-year-old son, and his phone broke a few weeks ago, and he was devastated because his life was on that phone. Well, yeah, I laughed, but he didn't. And it was good. We actually got to see more of him. You know, we have a data plan for him that is unlimited texts, and it's not unreasonable for him to send 6,000 texts in a month. And I think, Jesus, how can you send 6,000 texts? Disconnected operation is the normal situation today. 30 years ago, even 20 years ago, in academia and places like HP Labs, we were doing work on disconnected operation. What happens when I'm working on my laptop and the network is no longer there? I physically disconnect the network or it goes away. How can I make it work so that eventually when I reconnect, everything gets synced and there's consistency? And there were, a lot of work went into that, but it was still relatively blue sky research. But today, disconnected operation is the norm. We are pretty much working in that area today, where, okay, I have a phone that has 3G on it, but the 3G signal isn't that great. Certainly in the UK, it can go out quite a bit. And my applications on my laptop, on my phone, they have been developed to assume that disconnected operation will happen a lot more than it did 20-odd years ago. So applications, as I said, the power available on my phone, on my laptop, on my desktop, wherever, and in the cloud, it's quite quickly consumed by the things that we want to do with it. The type of application that we're developing now, 30 years ago, you would never have considered it except for, as I said, maybe in some research lab somewhere. And you might have thought this will be relevant to maybe 1%, or maybe even 1% of 1% of the population. Whereas today, I think, the vast majority of people need the type of apps that we're developing, and that's pretty obvious. You look at the Apple Store or the Android Store, and you see the success of people making millions of dollars on the in the Apple Store because there are a lot of people out there who have a need for these things. We're seeing a lot more online purchases, a lot more peer-to-peer interactions than we ever had in the past. In the past, distribution was typically client-server. Now it's much more peer-to-peer because that's the environment that we live in. But as we move forward through these more powerful, more complex type of applications, we start to see a need for things that many of us in this room will have taken for granted for at least the last decade or so, if you've been working in Java, certainly. Things like security and identity, audit trails, high-performance, low-latency messaging, database updates with transactions or without transactions, and workflow systems. These are all things that we're seeing people need in the mobile area, in the cloud area, and some of them are starting to reinvent the wheel. And hopefully, many of us in this room can persuade them that there's perfectly good wheels out there already. So just to give you a flavor of some of these apps, here's some peer-to-peer interactions that I'm seeing today already. So we're having ad hoc auctions. So we all know what an auction is. Many of you probably used eBay. This is an ad hoc auction system where there isn't central coordinator anymore. eBay is not involved in this. I'm walking along and I suddenly decide I want to sell my iPad, and I publicize it, and people who are in the immediate vicinity can start to participate and auction off that iPad. People are doing that now. 10 years ago, that was pie in the sky. I know because I wrote a paper on it. And we're also seeing people doing much more decentralized applications. Again, this peer-to-peer is dominating. The example that I've got on here is peer-to-peer based social networking. I always use the same example. I don't use Facebook. I know that probably makes me a heretic with, probably most of you are using Facebook, but my idea of a social network site is the pub on a Friday night with a pint of beer in my hand. So I'm gonna I'm gonna talk about something that I actually do not know an awful lot about, but I was at a conference in October last year, the High Performance Transaction Systems Workshop, and a group of academics got up, and so I'm kind of repeating, I'm channeling them. Apparently on Facebook, there's a thing called a wall. And this wall allows me to publish, or allows you guys, if you're on Facebook, to publish things, what you're doing. I'm eating some toast, or, I'm reading the newspaper. And the thing with Facebook is that information is maintained by Facebook. It's on their servers, and according to their rules and regulations, they can do a lot with that is outside of your control once you publicize it. So these academics believe that there's a need for social networking, but without a central service, without something like Facebook being able to control that data. So they have developed a peer-to-peer distributed social network system, that if you're involved in somebody's group, I suppose an example would be like a Google circle, you see that wall, but that wall is not maintained by a central service. It is only maintained by the peers. There is nobody outside of that circle who can see the information. And you join the circle and you see it, but if you leave the circle, it goes away. You can't get access to it again. So they've basically reinvented Facebook, but they've done it in a peer-to-peer way, and they've had to tackle issues like security, like fault tolerance, and and audit trails. I did say, I'm a bit of a game player, so I do play games. I have PlayStation and Xbox. It's kind of inevitable, I think, if you look back at what I showed before, things like the Raspberry Pi and the Beagle board. The next generation of dedicated consoles, so the PlayStation 4 and the Xbox 720, are very likely to be the last generation of dedicated consoles. Mobile devices in 5 years' time, which is probably when that generation of new consoles would be kind of end-of-lifing, will be so much more powerful than they are today, and so much more powerful than a company like Sony or Microsoft would want to try and compete with. So, just as an example, these two images up here, they might look like it's Call of Duty on one side and Halo on the other. How many of you have played Halo or Call of Duty? Hopefully more than me. Oh, not as many as I thought. Okay. All right, so these are not images from Call of Duty or Halo. These are actually images from games that you can get today that run on mobile devices, phones or iPads. So we're seeing that today now. We're seeing the power of these devices able to compete with PlayStation 3s and Xbox 360s. So, as I said, as the complexity of apps increases, the need for things like messaging, security, transactions, etc., increases. And hopefully I'm preaching to the choir here, but you look at this and you think, well, messaging, transaction security, I'm getting that today when I develop on my my favorite app server, or I'm using components that are out there in open source, for instance. These are things that we take for granted in the Java world. Now, obviously, Java is not the only language out there. And I tend to believe that, like every language, Java has a limited shelf life. But the JVM is something different. The JVM, I think, has a much longer shelf life than Java. And some of you may look at this and understand that this is not a list of all of the JVM-based languages that are out there. This is just a snapshot of some JVM languages. But it seems that almost every day, a new language, or a language that was not on the JVM to start with, is ported to the JVM. I mean, we've got Ada. I don't know how many of you have heard of Ada, let alone used it. But I was playing with Ada back in the late 1980s. And yet somebody has provided a version of Ada that runs on the JVM. Obviously, we've got JavaScript, we've got Python, we've got Erlang. So it seems that the JVM is really becoming the dominant platform for languages. So anything that we're doing in Java, anything that we have done in Java, can be made available to a wider range of languages. It doesn't just have to stay with Java, because I can access my Java transaction service or my Java messaging service in JRuby, for instance. I can do the same thing in Clojure or Erlang. So just because it was written in Java doesn't mean to say that it can only be made available to Java developers. So, what does this all mean? Well, I think that middleware is not dead. Mobile and cloud does not kill middleware. It should evolve. Certainly Java middleware should evolve. I think, as I said at the start, Java middleware should play a critical role in both mobile and cloud development for the next years, whether that's Java or the JVM. And it's ours to really make that happen. There are people who tie middleware to specific implementations, and when they say middleware is dead, what they really mean is this particular implementation, this particular stack, has no relevance to middleware or requirements for mobile and cloud, and they may well be right. But I think we need to make people outside of this community, outside of the Java community, aware that we have perfectly good components that may well have been written in Java, but can be made available to them, whatever language they're running on. We should not fall back into what, as an industry, we've tended to do very well for the last 40 years, and that's the not invented here syndrome. We should not allow mobile and cloud to be silos. If we do, then it's going to be inefficient, it's going to be expensive, it's going to be time-consuming. We did that, for instance, when Java came on the scene and supplanted Corba. For one reason or another, everybody ran out and started to re-implement their perfectly good C, C++, or even COBOL apps in Java, not because they really needed to be in Java, but because Java was the next cool thing, and I want to play around with it, so I'll get my boss to spend money and pay me for the next 2 years to re-implement something. We shouldn't do that with cloud and mobile, because there are a lot more things that we need to do. And just looking at Java EE6, it turns out that EE6 has a lot of these capabilities. If you look at EE6, compare it with previous versions of J2EE or even EE5, it's almost light years away from where it was. It's no longer a bloated stack. There's a lot of things that we did in EE6 to make it a lot more easily consumable in componentized form as well. And you may well have heard this, you may well have thought of this yourself, that Java EE is too bloated. But we've got to differentiate between the standards and implementations. And this is my one JBoss Red Hat slide. You should look at implementations of app servers that are out there today. For instance, AS7. AS7 is not bloated. AS7, a complete, full EE6 stack, starts up on a laptop in under 3 seconds. These days, in under 2 seconds. So it is possible to have a lightweight, full EE6 compliant stack today. And this is just a list of things that you guys are probably already taken for granted and know about: transactions, persistence, etc. These things are in EE6. They've been in lots of versions of EE and J2EE. They don't have to be consumed as a full packet. A lot of them will run by themselves outside of your full EE stack. So Java standards, I'm going to have to rush it a little bit, but the JCP has kind of been reinvigorated. Yes, there were some issues when Oracle took over from Sun and we saw Apache leave, but I think we've turned a corner now. We're seeing a lot more community involvement with JUGs getting involved. So the London JUG, for instance, is a member of the executive committee now. We're seeing the ME, SEE executive committees merging. There's a lot of work in JDK 1.8 and E7 that is directing it towards mobile and cloud. And importantly, open source is far more influential now. The fact that there are open source projects out there that allow us to get experience before we try and standardize on things is critical. Standardizing too early is a waste of time. Open source allows us to get experience and feed that in through the likes of, well, Red Hat, obviously, but also the London Jug, and there are other jugs. EE7 will be significantly better than EE6 as a result. But it's not all sunshine and roses. There are things that need to be addressed. You should take a look at that URL, but they include things like coordination, multi-tenancy, large-scale data storage, negotiation, so governance, and accountability. And I'm going to quickly go through just 2 of those. But if you look at that URL, you will see a lot of work that was done by various academics and people in companies like Oracle and IBM and Red Hat on where we think the future of middleware in general and Java middleware needs to go. So multi-tenancy. We've heard, certainly yesterday I heard some of this in one of the keynotes and one of the sessions. Multi-tenancy is extremely important in cloud and in mobile. We need to be able to cram as much onto these devices as possible in order to get the benefits, the low cost. Running multiple applications in each VM is extremely, extremely important. Unfortunately, Java middleware stacks are not typically architected for multi-tenancy. The JVM was not developed with multi-tenancy in mind. And we can do a lot in the application server and things that sit above the JVM to try and make them multi-tenant aware. But if the underlying JVM is not multi-tenant aware, then it's almost like putting sticking plasters on a knife wound. It's only going to take you so far. And we've kind of forgotten some of the good things that we learned in operating system classes. I don't know if it's the same in Germany as it is in the UK, but Java was good in one way, but it's really been really bad in another. We tend these days, certainly in the UK, and I think it's the same in the US, to teach undergraduates about Java and the JVM. They tend not to understand operating systems, and they tend not to understand hardware, and I think that can actually be a bad thing. And we're seeing that in terms of the JVM and its lack of multi-tenancy. So this is a typical middleware stack where you've got your guest operating system, you've got your VM, your JVM, and sometimes in the JVM you will run multiple apps per JVM, but typically you run a single app per JVM because that's the safest thing to do in a multi-tenant environment, because you don't want a thread that belongs on a completely different and unrelated client, if it goes awry, taking down the whole JVM and crashing unrelated applications. So what's needed, I think, for the JVM is that it needs to become a lot more like an operating system, or it needs to become a lot thinner, a lot smaller, have a much slimmer footprint. We need to get things that we take for granted in operating systems, certainly multi-processor operating systems, like Linux and Windows. We need to have things like red zone protection, so we can have independent failures of processes. We need to have real-time and deterministic scheduling. Dalvik, if you've got an Android phone, you've kind of got this already. Dalvik does a very, very good job at this, running a single app per JVM, but Dalvik is has a much smaller footprint than your typical JVM. However, there are issues around Dalvik, and again, they need to be sorted out in court. So we will see improvements in OpenJDK. We're seeing things with a 1.8 around modularity. We've seen OSGI modularity improve. These will feed into the JVM, and I'm sure it will become more and more multi-tenant aware over the next few years. It has to, if we are to succeed with, with what I've said before, with getting Java and the JVM to be a critical component of, or continue to be a critical component of mobile and cloud. Large-scale data storage, I'll skip through most of this because it was the keynote yesterday, but basically, relational databases were good in the past, but we're seeing big data and NoSQL come these days, and relational databases are no longer sufficient for all types of applications. And we'll see more and more work going on in the executive committee. We're seeing new JSRs around data grid. We'll see more effort, and we are seeing more effort in open source. And I think this is an active area of research. There's a lot of people out there talking about NoSQL today as though it's solved. It's not. There are some solutions that are pretty good for today, but I actually think that there's still quite a way to go in the NoSQL space. So, in conclusion, I'll say that I think the next decade is definitely defined by ubiquitous computing and could be and should be defined by Java and the JVM. Enterprise capabilities that we take for granted in your E6 stack, for instance, are a necessity today. People are reinventing the wheel in some of these areas that they don't need to reinvent. We need to educate them. We should be playing a leading role. But there are still a lot of areas, active areas of research to work on. So actually being a Java or a JVM developer today it's probably the best time to be a developer in these areas, other than back in '96 when Gosling and others first brought Java out. And I'll just leave you with this one slide and say thank you very much.